You know, it just made it so clear how special Earth is. And what makes Earth special is the ocean. The ocean is the cradle of life.
A Parent Wins, an adventure of a lifetime. A global expedition dedicated to collecting stories of environmental and cultural preservation while conducting marine research aboard sailing vessel Resilience.
So we were in Maine for most of the summer, and then we left from Rockland and headed south to Woods Hole.
So Woods Hole is this amazing place that I've heard about and known about for a very long time, but in Woods Hole, in this place, is Woods Hole Oceanographic Institution.
It's pretty much like a research mecca. All of these huge oceanography discoveries, it was always like Hui or Scripps, Hui or Scripps, Hui or Scripps. You know, those are both like the big oceanography institutions. And so coming from that and being able to go there, really, really cool.
Hui was started in 1930. Scripps Institute of Oceanography at UCSD was already in place, and the National Academy of Sciences wanted to have something like them on the East Coast. And for a long time, we were kind of a summer institution, that scientists would bring their labs here from Cambridge or Columbia or wherever for the summer, and then it would kind of closed down to some degree during the winter. And that all changed during World War II. We got a tremendous amount of funding from the Navy. We discovered something called the SOFAR channel, which is a layer of the ocean that carries sound particularly well. So if you're a submariner, you want to stay away from there so they don't get discovered. And if you want to listen for somebody else, you do want to be there. And apparently, after that discovery was made, the US lost no more submarines in World War II.
We went to Woods Hole really with an effort of building our scientific capabilities and looking for guidance on how we can make Resilience a really effective research vessel, and looking for guidance on how that we could actually contribute to meaningful data collection and research. Carrie's one of the first folks we met. She actually runs the ROCKS program, which is research on commercial ships, but also she's in charge of, I think, a lot of things, including running the dock. So she was the first person we had to talk to when we even got to Hui. I guess we had an email with Jim, a couple conversations, but Carrie was the next person to allow us to be on the dock. And she manages everybody coming in and out of Hui by the water. But with Science Rocks, it's a pretty incredible program.
When I came to Woods Hole Oceanographic, I thought I had this original idea, you know, because I came from commercial shipping, and here I am now working for the science community. I'm like, you know, a lot of these commercial ships can do science. You know, they can't do everything. They're not going to launch a autonomous vehicle or do any coring, but they can do other things. They could monitor, you know, have sensors on the ships, and they can launch, you know, Argos. So I had presented it to my boss, who's a great guy and very empowering, and said, you know, go run with it. And I ran into a guy at dinner at the University of Rhode Island, Thomas Rossby, a very famous Swedish-American scientist. And I thought I had this original idea, and he's like, I've been doing it for 30 years, and so is Noah. What's great about it is it's already been implemented. So, but what I was thinking was bigger, and he liked that. So he's had one vessel all these years, and I think Noah was maybe a half a dozen. They had some pressurized CO2 sensors on some commercial ships over the years, but just a handful, right? And then this other scientist, Tom Rossby, had just the one ship, which is great, but you know, when you only have 100 research vessels around the world, and there's 50,000 plus cargo vessels, and we've only explored 20% of the ocean, you know, just do the math. Like if we can put even 2% of get 2% of the commercial ships to do some science for us, we can cover a greater area in a shorter period of time. So yeah, my hope is that we get on 2% of the commercial ships and, you know, multiply measurements and observations and get a better understanding, kind of like what you want to do. Yeah, with apparent winds. Yeah.
Understand better, right?
Yeah, I mean, it boggles the mind to think that we're exploring space and we probably know more about space than we do our own oceans. So to me, it's a priority. It's like, can we be a supplement or an addition to what the research vessels around the world are already doing? Very often we're in our own silo, right? We've all got our own focuses, but if we just take those off and talk to people, and it's amazing. We're so connected, and we can do more to help each other, and just with some little more efforts or open-mindedness.
It's really cool when we see things like the shipping industry and science, which you might think are two completely different entities with different motives and maybe even butting heads a little bit. But to see that the reality in this case is that you have the shipping industry wanting to help with that scientific effort, with that research, because they realize that it does affect them and it affects the rest of the world. And if they're in a place that they can help, they will. We went into Woods Hole really with not a lot of knowledge, I'd say, and a strong desire to learn.
And we got talking about doing science on boats, and specifically what we could do on our boat. And so brainstorming with both Carrie and Jim, they were thinking, what about Argo?
We ended up sitting down with Susan and Bill, who are both folks that work with Woods Hole Oceanographic Institution with Argo.
So my name's Susan Wafels, and I'm a scientist here in the Physical Oceanography Department at the Woods Hole Oceanographic Institution. Argo is actually older than the movie. So it's a program that's been going for about 20 years, and its main goal is to kind of measure the slow, seasonal timescale changes in the global ocean. And we do that by using robotics, a large number of small robots called profiling floats. And the goal of the global program right now is to have around 3,000 operating, spread all through the global ocean, one float about every 3 by 3 degrees. And it's a great example of international cooperation. We have about 20 countries participating, deploying floats, acquiring floats, looking after the data management of the program. And a hallmark of Argo is that all the data is shared with everybody. As soon as the floats get it, we try and get it to onto the internet and out to operational forecasting centers within 24 hours. Actually, now it's much, much less than that. And so the original Argo, which started 20 years ago now, it's been a really successful program, only measured temperature and salinity, and it really has revolutionized research about the ocean and the ocean's role in climate. But now Argo wants to do the full depth, so we now can build floats that can operate down to 6 kilometers depth, but the current array only measures to 2,000 meters or 2 kilometers. And we're moving into the ocean carbon and biogeochemical system and starting to measure optical aspects of the ocean that tells us about the plankton field. So we're moving into biogeochemistry and ecology. And so, those are 2 big new missions, the Deep Argo mission and the Biogeochemical Argo mission, that right now we're sort of ramping up.
This is our standard float. So you have your top cap, which is this piece up. These are individually calibrated. This sensor is a Seabird CTD, which measures your conductivity, your temperature, as well as your pressure. Your temperature and conductivity are used to determine the salinity of the water or how salty it is. So this is the main sensor suite up here. From here to here, externally is our pressure housing. Inside the main part of the housing here, we have our internal chassis. So the chassis holds our batteries, our control boards, as well as our internal reservoir for oil. And that's what's used to change the effective density of the float. So how these work is we ballast them to a specific target depth in a specific ocean. So different oceans have different salinity values and temperatures, you know, different waters essentially, and that changes our ballast numbers. And then how they work is as the float goes down, everyone always assumes water is an incompressible fluid. Fact is it's not. If you squeeze it hard enough, water will change its density, and these floats compress slower than water does. And so the idea is as they go down, the seawater is getting denser at a rate faster than the float is, so eventually it becomes neutrally buoyant at the target depth. Once we get down to the target depth, to ascend, you move oil from inside the float out the bottom where there is essentially a half a softball-sized rubber bladder. And once you move the oil from inside outside, it reverses direction on the bladder, therefore increasing the volume of the float, making it less dense, making it come back up to the surface.
Just like weather forecasting, which is a triumph of international generosity and collaboration, right? The weather forecasting system is maintained by satellites and giant supercomputers and amazing mathematicians, and all the forecasts are shared by the world. Everybody gets those forecasts, right? And it saves lives every day. We're trying to do the same thing on the ocean side. And so, you know, that culture in our area in climate and meteorology and ocean sciences, you know, that culture of sharing is very, very important and very deep because no nation can do this. The job is just too big. We need every nation to help. And so it's a really excellent, you know, problem-solving group amongst many different countries.
Without programs like Argo, we wouldn't have a lot of the necessary data that we need to do accurate weather forecasting, to understand ocean currents, to understand the effects of humanity to nature, or on nature, and just how this world works. The ocean's such a massive portion of our world, and we don't really know that much about it. So the map that we're looking at is Argo float coverage. The one I'm looking at really is healthy floats. But the dark blue is dense coverage for Argo floats, and the yellow is very low density or no floats in that area. And so talking to Susan, she wanted, basically they want to deploy floats where they're needed, which would be the yellow places or the highest need. And so if we're looking at this map here, I can zoom in and see that, for instance, the western coast, off the western coast of Mexico, and then south of Panama, or south of really Panama and Nicaragua, Costa Rica area, and over by Ecuador and Peru, there's a huge area with yellow where they have no floats. And that's the area that she's already sort of expressed as a high need area. There's some in the Caribbean as well. I'm kind of curious about that just because I know they do deploying there, but she said it's also a high need space and they need more modern floats out there. And then if I look at the map, we can follow after Panama and after this sort of western corner of South America off the coast, we just see what looks like just egg yolk spotted all over the Pacific and Oceania, which seems like a high need area. The big thing is we also can't go into the the exclusive economic zone for each area. So meaning that I think we have to be about 3 miles or more offshore.
No, 200.
So one tricky thing with some of these areas, all in the Caribbean and in the Pacific and Oceania, is that you can't be in the exclusive economic zone. So we have to deploy out in the ocean and then hope that they drift into those areas. And we can get permission to deploy right off the borders of those areas too. All right, so if this was an Argo float, it'd be very heavy. We bring it down, but not too heavy, just not an empty box. So now let's set it down here, and we'd be putting them stacked up here. So let's see how many we can fit in the salon. Okay, so there's...
So maybe we do 2 of them and just secure this whole side of the room.
Right, so let's see, I'm gonna just roll this. So that's 1, 2. My question is, could we do 3? I think we can do 3, 4.
I think we could.
The only stuff, we have camera equipment in here, we just move it for this. So 4, could we do more? 1, 2, 3. And go up here.
When we started Apparent Winds, I suppose I had hoped that we would be able to contribute to this type of research, but I don't know, it seems so almost far-fetched that I didn't want to like get my hopes up. And so it's really incredible to be working with scientists like this and of this caliber, because it's an incredible program. The Argo program, the Science Rocks program, just HUI in general, they're really incredible, passionate, driven people.
I grew up in outback Australia, far away from the ocean. My mom's a librarian. And so even though we lived in these pretty remote places, she had a lot of educational material in the household, and I think she got some magazines from NASA, of all places, some kind of educational things for kids in schools. And it talked about the planets in our solar system and that they have climates, right? They have atmospheres and they have climates. And then so we compared the climate in Venus with the climate on Earth, and you know, it just made it so clear how special Earth is. And what makes Earth special is the ocean. The ocean is the cradle of life, right? It's really quite remarkable, and that made me think, well, that's so cool. I want to study the oceans and how it helps Earth be livable and the role it plays in our climate.
Really going to Woods Hole, just in general, is super inspiring. To go to the campus and meet with, you know, Susan and Bill and Carrie and Jim and, you know, all the other folks that we met with, it's just so cool because you have such incredible talent and so many incredibly intelligent people that are also just so warm and kind. I just love that community. I mean, out of that visit from Woods Hole, we came up with the idea that we can, I think, very successfully and effectively deploy Argo floats, meaning that this boat that we're sitting on, Resilience, will be a boat that deploys floats. Those floats in turn will collect oceanographic data that will be used worldwide. We are in Woods Hole at the Woods Hole Oceanographic Institution dock, and we are headed for Montauk today. Weather looks good, and I'm hoping Montauk. We have 80-some miles to go.
This season is coming to a close, and we're gonna start heading south soon. I don't know, I'm excited to get headed south. I know Tripp is very excited to go back to his home.
It's just super exciting. I can't wait to see what happens this fall and winter as we go through the last sort of stage and process of changing this sailboat, which used to be a sailing yacht, into a sailing research vessel. If you want to access more content, consider joining our community on Patreon. You can find details in the video description. Thank you so much for watching.